third law of motion. So, just a quick recap on Newton's first law. Any object wants to stay in motion, or any object at rest wants to stay at rest unless acted upon by an outside force. Newton's second law is any force acted upon an object moves that object in that direction. So like a kickball. Then Newton's third law here. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force back, known as the action-reaction forces. So basically, if one person pushes on the other person and that person pushes back and neither of them move, they're exerting opposite forces on each other, equal and opposite forces on each other, and neither of them are moving. So how would this work in real life? Okay. If you take swimming, for instance, okay, when you swim, you are grabbing the water. Okay, you are applying a force to that water. The water is applying a force back on you. Okay, and that's why you're able to grab the water and move your body, because the water is applying a force to you. In this case, the water is applying less force to you than you are applying to it, and that's why you can move in water. If you take your hands and press them on the edge of your desk, go ahead and do it. You might notice that your hands, like the skin along where you're pressing, gets like white and maybe like kind of changes shape a little bit. Well, that's because that desk is pressing back on you. You are applying force to the desk. That desk is applying force back to you. Okay, so it could be like if I go up to a brick wall and I push against it like crazy. I push against the brick wall. The brick wall is probably not going to move. Okay, I am not going to move the brick wall. I am applying a force to the brick wall, but the brick wall is also applying an equal and opposite force back to me, and that's why neither of us are moving, because we're canceling out forces. Okay, let's imagine if I had a like a big like refrigerator box, okay, and one person was pushing on one side of the refrigerator box and the other was pushing on the other side, okay, and if they're pushing at an equal force, the box is not going to go either way, because they're canceling out. Okay, that's basically Newton's third law right there. Okay, you set your book on your desk. Okay, your book is applying force to your desk. The desk is applying force back to your book, and nothing's happening. Your book isn't falling through the desk, and your desk is not pushing the book off of it. Okay, it's the same exact force, and it's canceling out. We'll come back to that here in a little bit. Another example, if we use a football example, if someone's trying to block and someone's trying to make a tackle, okay, if the lineman is blocking the defensive lineman, the offensive lineman and the defensive lineman are tangled up and neither of them are really going anywhere. Okay, the offensive lineman isn't pushing the defensive lineman away, but the defensive lineman isn't getting away. You would say that their force is canceling each other out. So, what does Newton's third law state? Basically, that every object exerts a force on other objects, an equal and opposite one. They don't always cancel out. Okay, if I pushed someone really small, okay, and they push back on me, odds are that person would go the direction I push them because I'm bigger, I have more mass. Remember, things with more mass tend to be harder to move. If you've ever let the air out of a balloon, this shows this really well. If you blow up a balloon and then let it go, okay, the air is going to shoot out of the balloon, and the balloon is going to shoot away from where the air is. So you can see, basically, the air is pushing the balloon to go somewhere. I'd like you to watch just a couple minutes here. Today's lesson is going to be pretty short. It's difficult for me to show you these things, so we're just going to watch this.
Welcome to the European Space Agency, ESA. Newton came up with 3 laws of motion, laws that describe how forces and objects relate to each other. Hi Pedro, Alexander. We can see that they're floating. They're pushing against each other and move apart. That's an ISS battery and it looks heavy. That means it has a lot of mass, right? Once again, they're pushing against each other, but Alexander moves less. What we see this time is that for every action, there is an equal and opposite reaction, Newton's third law of motion. Alexander pushes against Pedro, action. This causes Pedro to move, reaction. At the same time, Pedro pushes against Alexander, action, causing Alexander to move in the opposite direction, reaction. And they moved an equal distance, action equal opposite reaction. The battery's mass is about 80 kilograms, so now the force is the same, but the mass is different. Remember Newton's second law of motion. Action and reaction are caused by the same forces, but they're expressed through different mass. Therefore, Alexander moves less. Let's see what the schools are up to. Here we go. This is like Pedro and Alexander on board the station. We add another girl, and they don't travel as far. The force of throwing the ball makes her move backwards. A collision, that's a force. But do you know why only the guy in front moved? The students are arranged in what we call a Newton's cradle. Skater collides with the first student, action. The first student tries to move away from the skater, reaction, but can't, because there is another student in the way. So, the force of the impact is passed through the next student and on to the end of the line. Then there's nothing stopping the last student, so off he goes. This is like the guys on the ice, only the last ball moves. And here the 2 balls are moving, but they don't seem to go as fast. This is because the same force is travelling through the cradle, but is expressed through twice the mass. As mass and acceleration are related, the 2 balls travel less than the single ball. The third law helps us in other areas too. Space vehicles use it to lift off. The air or gas is heated up and forced from the exhaust, action, and the reaction pushes the rocket up into space. Now you know about Newton's 3 laws of motion. Law 1 states that objects at rest or in motion stay that way unless a force acts on them. Law 2 says that the force is related to mass and acceleration. And law 3 says that every action has an equal and opposite reaction. But why should we learn about Newton's 3 laws?
And we'll call that good.